Yo, what up? Is this thing on? Hello? Hello, hello. How's everyone doing? Good, I hope. Let's see. We'll get a couple things open and running. Want to make sure the code for this thing is working, because it probably isn't. It normally doesn't. I'm working on some updates to it. Oh, I gotta update the address for it. But I'm working on some updates for the breadboard code, so it can be a little bit more robust, have some more features, that kind of stuff. Right now it still sucks. I mean, all my code sucks, so. Okay. How about that? There we go. Okay. That's working. Cool. And get some music going. So I think where I was last time. So I was digging into this over here, just like the clock circuit, I think. Pretty sure that's the clock circuit. Let me take a look at KiCad. What do we have going on? Where was it? This over here. So this KO pin is going to a resistor network. And then going to the rest of those pins, right? I don't know what the point in that is. Let's see, where's my KO pin? What's this one right here? Oh, this goes to the clock pin. Right? That's CK1. Why do I have that as the... Or am I looking at the wrong pin? KO goes to this 3300 K resistor. Which one was it? This one? It was that one right there. This one right here. Oh, wait, that's the that's the 3300? Yeah, okay. Yeah. This goes from over here to the clock pin. Right, and then does the clock pin go to, yeah. Wait, how's that the clock pin? I'm gonna have to double check some of my work. Obviously. So this is clock pin from over here. This is the start of the clock pin. Comes to here. We have this trace that runs through the board. Over to here, and then down here. And then the clock pin tees off from here through a resistor over to our KO pin, right? That's that guy right there. And then goes the other direction to our resistor network. So I don't think we have that right. So I think this needs to be going to our clock pin. Yeah, because this goes to the rest of our, like, D1, D2, D blah 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 blah, right? So that one, or is it D2? Yeah, D2 goes to this resistor network. Okay, so that doesn't need to go over there. Instead, we need to have this connected here. And let's just move this. That goes to our clock pin as well. Yeah, that's fine. Whatever. Yeah, resistor goes to our KO pin. And then the rest of that goes to that resistor network. The rest of our pins. Okay, that looks better. Yeah, clock pin over here to here. This is straight. Clock pin, there's nothing else in the way. Okay. I think that's right. I had that wrong because I never went back and double checked it after I laid it down the first time. So I think what this is doing is it's generating the clock source. These two transistors are acting like a flip-flop, I think. Don't quote me on that. I have to double check it later, but I think what I want to do for diagnostic sake is check out the power circuit, like over here on the thing, and see what this thing is. I think this is a transformer, and because we're trying to drive VFDs, vacuum fluorescent displays, these little dudes, since we're trying to drive these, all the documentation that I can find on like these tiny VFDs says that they should be running at about 24 volts. And I haven't probed 24 volts on this board anywhere. And the main voltage for it is 6 volts, so there has to be some sort of boosting or transforming going on. And I think this is a transformer, but I haven't been able to find any data sheets about it online yet. So I think kind of mapping out the circuit in KiCad up to this part and trying to figure out like the supporting components around it. Maybe we can determine if that's actually supposed to be a transformer or not, and if it's not working right. Because I can't really open it up, I don't think. It looks pretty sealed. But it's transformer shaped. It has like a transformer number of pins, if that makes any sense. Yeah, this looks like a transformer to me. And this is kind of like the voltage power area, I guess, because there's a lot of capacitors. We also got some screen printing on the board. This says VF1, that says VF2. So I don't know. Let's try to work our way up here and see if we can't figure out what is going on. So this is our VGG, which is supposed to be voltage ground. This dude right here, negative voltage. I don't know what the difference between that and VDD is. Let's see. Homework help. Yeah, I got homework. Drain source emitter. I guess that would help, right? So is that VCC? That's a G. VBB? What the hell is VBB? Where's VBB? Is that battery? Voltage battery? Virtual breadboard? No. No letters refer to power supply voltages. Yeah, I guess it is battery. VBB for battery. I'm gonna assume that until proven otherwise. Okay, so maybe we can go up this way, over here. Work our way up towards this power circuit. I think that's probably our best bet. I believe this is a MOSFET. Probably going to be used for doing some sort of switching. I have no idea. I don't know how to get over to this MOSFET from here, though. Where does this actually connect? I may have to look at it from this side. Oh, it all looks like it all runs up this way. So we're probably dealing with these main connections over here for power, right? This VGG1 over here, and BSS. There's a ground connection. How is that a ground connection? This is coming from all the way over here. Okay. Do I have anything for that yet, or no? Yeah, that would be this one. BDD14. Oh yeah, I've already got it marked up here. Okay. Wow. We've got our supply voltage, our ground. Okay, and so this pin is connected over here to this leg of our MOSFET. Or at least what I believe is a MOSFET. Let's see. This little doohickey right here. It says, alright chat, are you ready? 01226A Q 0.2K. I think that's a point. Alright. Did you get that? You write that down? Good. Let's see. Samsung, no. It's a Matsushita. Matsushita, which is Panasonic. Ooh, I wonder if my, archive.org book has it. Oh, booth. They even have MOSFETs? Silicon MOSFET. They got 3. Is this a MOSFET? I don't know. It's easy to make assumptions about what a part is. I guess you could test the legs, but I don't know. Alright, let's see. Test if part is MOSFET. How do... Simple test for a MOSFET. That not in circuit. Okay, so I could desolder it? Power MOSFETs usually feel shorted, which means if the I don't think this has failed or anything, because there is power on this end of the board. It is only 6 volts, so maybe it is bad. Since you know which pins are drain and source. Okay. Put this sucker in diode test mode, right? Okay, so I know this pin is ground, right? So test that now. No? Maybe because it's in circuit. Okay, so this is just likely the what, TO220 package. Lateral MOSFET sources the center pin and the tab. More common vertical FETs have drain in the center and the tab. It's something like 0.1 ohms, but between any two pins, time to desolder it. What is this dude talking about? Use your fingers as variable resistance? What? Or other linear power stage. Yeah, I think that's where this sucker's at. Right here. Oops. Okay, well, I feel like it's probably working. I don't know. We could pull it out of circuit to figure out what its properties are. Maybe we can just find the part. That's that part. I tried finding the part sheet for this thing, but I couldn't. This Calc Museum doesn't actually have the datasheet for it. Let's see, what was I gonna look up? Oh yeah. That's pretty dang close. What's the difference between Q? SC1226A. Oh, you know, and they're probably not in this one. They're probably in this catalog. Although, I feel like it wouldn't be. Nope. I mean, MOSFETs are semiconductors, so I guess it would be in the other one. These are like diodes and stuff. This dude. It looks like this. It may not be a MOSFET specifically, it may just be a type of transistor. Which, I mean, I guess MOSFETs are, but it's all confusing. Oh, that's a weird one. Look at that dude. One, two, two, six, eight. There it is. Just see 12268. I guess the T30 package. What is the T30? Wowee! I found it. What is this used for? Output? Okay. Right, so let's see if we can find the package for it. So it says it's a T30. What page is this? Page 18. Hold on. What was the fucking part? Oh, here it is. Alright, base collector emitter. Right, there's like a cutout on it. Oh, there is a cutout on it. Look at that. Okay. Oh shit, it's backwards. What the hell? Okay, well, that's the emitter. Base and collector. Yo, what up? How are you doing? I don't know. This is kind of sus. It says it's totally not bright enough, is it? Wow. it says that this part, this little doohickey, it's got a cutout, right? It says that that cutout, if you have this orientation, means that this emitter pin is going straight to the ground. Is that? I don't know what the purpose of that would be. And again, I don't know a lot of stuff, so. Okay, let's not mirror it. Maybe that's adding some confusion. Seeing this pin right there, the one that's on the left. It should be this one. Oops. I'm doing pretty good. It's a Monday. Working on some reverse engineering. Yeah, so it says that pin should be the emitter. Oh, that kind of makes sense because that's going to like the, no, wait. That's going to the negative on all of these. Is that the ground? Yeah, the one on the inside of the board. Okay. I think I want to, mirror these two layers. Let's see, transform the mirror horizontally. Layer, transform, mirror horizontally. Oh, maybe I should have not done that. I want to avoid the problem of having this text mirrored because the document is mirrored. I don't know. Like by default, I have the board images mirrored. It's kind of annoying. Okay, oh yeah, look at that. Yeah, we'll... There's a digital room, that's funny. Nitpicking. Well, my goal at this point is to just get it working, because right now it doesn't work. And I don't know enough about electronics on a hardware level to fix it, or at least diagnose it yet. But my idea is that by the time I've mapped out the whole circuit in KiCad, as we've got going here, once I've got the whole circuit kind of mapped out in KiCad and I've got a schematic of it, I'll be able to study it and figure out why it's not actually working. And then once I get it working, I'll have a bitchin' calculator have a really cool calculator. And I'll know a bit more about it. And if it ever breaks on me, I can just fix it. So that's kind of the idea. It's a cool calculator. Alright, well, I guess I'm going to continue with this pin. And we can kind of start mapping this in KiCad, because I've got enough of this over here for our VDD. I think that's what I called it. Where did I get VDD from? Oh, is that on the that's on the actual chip itself. Yeah, right here, pin 14. Is that bridged? That's bridged. I guess we can count that as a VDD pin as well, right? Good. Yeah, it's definitely a long process, but I'm learning stuff as I go. So I think it's all worth it in the end. Learning how these individual components work and how people from the 70s were way smarter than me. That's going to that right there. Doop. What else we got coming off of that up here? That's about it for that thing. Okay. Alright, I think we ran this one down. I think we've got all the pins mapped out for that. For our VGG. Does this get over to here? Is that a... Nope, that's just straight bridged. Okay. Doesn't actually pass through any components, it goes straight through the printing on the board. Over here, back to the... Is it pin 14 on our chip? This one right there. Which according to this is pin 14. Okay. Yeah, right? And this is a calculator from the 70s. So everything's been, like, bigger. All of these parts are a lot larger, like all these transistors. A newer calculator would have basically all of this junk kind of packed into, like, one chip. One of these integrated circuits. It could kind of be like some sort of microcontroller, probably. And it would be, like, multitudes faster. But it's very interesting to see, um, like the difference in hardware from the modern stuff that I'm used to working on at like a software level compared to like a simple calculator from the 70s. But I really like how modular it is and how repairable it seems to be. Like for instance, these buttons on the boop, 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 boop. The buttons on the calculator are pretty sweet. They've got like they're on this little rail with magnets, and the magnets activate little reed switches, and the reed switches are like little vacuum tubes. I don't know if you can see them. It's kind of let me get my point and stick. Where's my point and stick? Oh, there it is. But there's right in there, it's like a little tube, kind of runs back and forth right there. And inside that little glass tube is a little spring switch that gets activated by the magnet on this rail when you push the button. So the buttons don't really have a whole lot of like wear components, which is very neat. And then the way it's assembled is pretty cool. It's very simple and straightforward. You got a couple connectors, which are very nice. And if I can get this, oh, here. Put the screen on the board first. Goes like so. Everything kind of just fits together nice and snug. So it's pretty cool. And the calculator's got some BFDs, which are like little fluorescent displays. It's like some old-timey glass tubes. That's mostly why I want to get it working. A calculator with some BFDs is really cool, in my opinion. So that's my main go. Yeah, larger does make it a lot easier to reverse engineer. At least the circuit. I would say the circuit board. Because like with like newer stuff, a lot of that stuff is abstract. A lot of this stuff is abstracted into or abstracted away into an integrated circuit or a microcontroller. But at a higher level, you don't necessarily need to know like what everything on the board is doing at like a basic level. Like you don't need to know that these are transistors doing switching or something like that, depending on what you're trying to do. If you're like trying to reverse engineer the PCB on some new modern electronics, it's way trickier because there's so many more layers to the board. You know, modern electronics can have multiple layers to the PCB. Like, I don't even know what the max is, but I'm pretty sure there's like 7-layer boards, probably even more than that. And so that's like 7 layers of traces all running throughout the board, which can make it very complex and super dense. And in my case, I've literally only got 2 layers. I've got a front and a back. So it makes it very simple. I would say it's a pretty good starter project for learning this kind of stuff, which is good for me because I don't know shit about, you know, electronics on a component level. I work with the reverse engineering stuff on a higher level mostly. It's like software. And sometimes getting into the hardware is like dumping firmware. So it's a fun project for me to learn from. So this stuff up here I think is all the power circuitry, and that's kind of what I'm working on reversing now. I've got a whole bunch of other layers in here with pins that I've kind of mapped out. And the idea is, so like this section over here for like the VGG or the ground, you can see it kind of comes up over here. VGG is all of this stuff over here. So far. There's more to it that I haven't mapped out on the schematic, but hopefully once I'm done with the schematic, I can figure out what's wrong with it. And if not, at least I've got a schematic, which is cool. What on earth am I doing and why? I'm reverse engineering a calculator from the 70s. So I'm trying to figure out, A, why this one isn't working, why it's broken, and the display doesn't light up. And B, reverse engineering it so I can learn more about the board and about what all these parts are doing. And just, it's kind of fun. Tedious and fun. The VGG15? No, which one are we on? EDD14. I want to move this down. Of all these V pins by themselves. I don't know if that's a good idea or not, but... So this is pin 14. How does this compare to the rest of this junk? Okay, I still think that's all separate. Okay. Now, why am I calling it VGG? Is that the VGG pin? Pin 15? Where is it? Yeah, right there, VGG. Okay. Sorry, I get a little caught up in doing stuff, and I don't realize that I have my capture on the wrong screen. FPV, is that like first person flight stuff for like drones? That stuff's pretty cool. I've been meaning to make a drone, but it is something that I have yet to get around to. Thanks for hanging out, client. I'll see you around. Have a good night. Oh, and trust me, I am not a mathematics geek. So... Math is actually not my, it's not my strong suit. Perhaps even that's why I'm trying to fix a calculator, is because I'm not good at math. Okay, so... yeah, let's get started mapping out VDD, which is this guy right here. What do we want them going to? Let's figure something out first. I wanna do this stuff up here. So... let's get up here. I guess let's just start with the first damn thing that we see on our VDD rail. So coming off of the chip itself, do you have anything on this side? Do not see anything. Okay, so no bridges there. Gonna flip this sucker over. And then this thing, what is this thing right here? What is that pin connected to? So this is a transistor. Is that the C481? No, that's the A749. That's the A749 transistor. So let's just put I didn't what did I use for these? Just regular old NPNs. Okay, I'm gonna check my sheet. Not this one. Close that. Close that. Where is it? Here, the A749, right? Yeah, A749, 49. What type is it? I don't need all the details yet. The switching. Okay. Did I not get that? Oh, I have that other page in a different one. That's PNP. Okay, so the A749 is a PNP transistor, which is really, I think, all I need to know for now. As I put this, just a generic PNP transistor over here. No, I do not have an electrical engineering degree. I'm just kind of learning the shit as I go. So we got our VDD pin, and what is this connected to? This is which leg on it? It's the one to the right. So if we look at, so you see how this sucker is facing this way? At least the flat side of this dude. So if we go and we look at our chip, let me move these over to our other workspace. Okay, so now we can see these over here. Not this one. So this is our package, right? And we've got our flat face right here. So pin number 1 should be on the right-hand side, right here, I believe. That's going to be the emitter. Then we have our collector and then our base. So we can connect this to the emitter. And we're going to be connecting other stuff to this VDD rail. But for now, it's connected to that. And let's keep following this. What is the next thing that it's connected to? This goes to a capacitor. At least I think that's a capacitor. Or it's a resistor, maybe? It says a 102K50W. That may be a resistor. we could test it. 102K. So does that mean it's supposed to be 102 kilo ohms or 102,000 kilo ohms, right? Or is it this sucker right here? Ah, noted. Noted. Okay. this dude right here. I'm going to test resistance of this. $408, right? 409. I think that might be a capacitor. No? Is that 571 ohms? Huh. Interesting. Let's see if we can just find out what the hell it is. Yeah, I think it's something like this. It's a capacitor. Well, porcelain capacitor, because when I first started probing it, I saw it like kind of ramp up. Maybe we can ground it, right? Um, I don't know how we'd be grounding it. I don't really have a battery or anything. It might be a capacitor. It looks like a capacitor. Doesn't really test like a resistor. We'd be getting the reading that we should be getting from it if it was a resistor. Thanks, doo-doo. Let's see. I've also got a, you guys are interested, I've got a breadboard you can play with. You can send commands to it through chat with exclamation point and make it do stuff, which is pretty fun. Oh, hold on, let me make sure my code is actually working before I tell you guys this, right? Classic. Classic dead code. Hey, what's up, Tibet? Nice to see you again. Oh, this little dude, right? 102J, though. I don't know how much of a difference that makes. Alright, I'm curious to see what if it actually renders. Nice, that's not bad. That got all of it. Cool. Also, I think I fixed some of the delay. I improved the delay. So hopefully that makes it a little bit better. Yes, I think we're dealing with a thin film capacitor. Or it might be a ceramic capacitor. Not chopping. I want chopping. That's just trying to sell stuff to me. well, I do not think, we'll just put this as a capacitor that is not polarized. Do not believe it has a polarization to it. So we'll do that. That takes care of that, this dude right here. And then we've got, where's that, two more of those A749s. Oh, one's actually a NPN, one's a PNP. So the first one's a PNP, and this one's a PNP, this one's an NPN. I think I got that right. Yeah, PNP, NPN. So I will need to grab one of these. And another one of these. What did I say the first one was? First one is the A749, so it's this dude. Get our capacitor first. Let's get the back of this. Yeah, the problem is the calculator doesn't work. I can't get any display on it. So it turns on. I can tell that it turns on because I supply power to it, and I can probe the board while it's powered, and I don't get anything throughout most of the circuit until I flip the switch, and then I get 6 volts, which is the supply voltage, and that runs through the calculator mostly. So it's getting voltage across most of the board, but the VFDs, this whole board right here that's got the displays on it, the actual tubes, is only getting 6 volts. And the documentation on these low voltage VFDs, everything says 24 volts is like a minimum that they should be receiving. And so I'm not probing 24 volts on the board anywhere. So I'm thinking that the circuit that's responsible for that, or the part of the circuit that's responsible for that, is this little doohickey up here. I think this is the transformer, and it's supposed to step that voltage from 6 volts up to 24 volts for the VFDs. And I think this isn't working, but I can't tell if it's a transformer or not because it's just a black box. It's a literal black box problem. So right now I'm trying to map out this side of the circuit to figure out what's going on with the voltage. See if maybe there's a way that the voltage is supposed to be, converted to 24 volts. In terms of solution, I think if I can determine that this is actually a transformer and it's supposed to be cranking out 24 volts, then maybe I can take it off the board and swap it with an off-the-shelf 24 volt 6 to 24 volt transformer with the same kind of pin layout and give it a test and see if maybe the VFDs start working again. So I'm hoping I'm hoping it's something simple like that. I already went through and I replaced all the capacitors, which in hindsight is wasted effort. If I knew more about circuitry and like electronics, I could probably have started somewhere a bit more intelligent, but I'm an idiot, so I'm starting from the ground up. So I've got over here this whole pin coming off of the integrated circuit, this VDD pin. I've got coming down here, and I'm just kind of starting the legs off of this that start going into this circuit up here, which is I'm hoping the transformer circuit, or at least like part of that. So I've got this dude, this is a NPN or a PNP transistor, this is the NPN transistor, and then we have a capacitor. It's a polarized capacitor. So that is another one, and then we have our MOSFET, I'm guessing, or no, that's just a another transistor, which I guess is a MOSFET. I guess it depends on how you make it, I don't know. So let's get that thing. There's our other capacitors. So we've got, this is our first PNP. Then we got this capacitor, right? And let's get another one. Give me the capacitor. Do we just have a generic ass capacitor? Where is it? Device. Polarized. There it is. Generic polarized capacitor. And we got the negative leg going to that. Yeah, so negative side of that is going to here. And then we've got another transistor. This is this guy right here. 1226A. Silicon NPN used for output. I wonder if this is supposed to output 24 volts. Do I have the... Oh, you know what? Where are the specs? 2SC1226A. Give me the specs. Oh, there it is. There it is. Wow, I cannot draw a straight line to save my life. Wow. I'll be a perfectionist about highlighting this shit in the PDF real quick. Hold on. Oh. Alright. Close enough. Okay, I'm done. Alright. So what is our spec on this thing? I wish I knew all of these acronyms. So we've got like our collector base, right? Collector something another. I don't know. I don't know what all this shit is. That's our maximum ratings. VCE voltage collector. Okay. Okay now. Let's see. Silicon transistor characteristics. Or if I can just roll it just straight. Nope. Collector emitter voltage potential difference. Thank you, robot. Now, can I get just like a full fucking page? Where'd you learn this from? Alright, kids, let's go to class. Small voltage forms between those nodes. Transistor datasheets will define this voltage as CE saturation voltage. Voltage from collector to emitter required for saturation. This value is usually on 0.05 to 0.2 volts. This means that collector voltage must be slightly greater than VE, but both be still less than VB to get the transistor in saturation mode. Oh, that makes sense. Okay. There's like, I guess, like a little bit of leakage. AI is okay. It's alright. I just feel like every time I use it, I can feel the temperature of the earth increasing. When I could have just done a little bit of more Google searching. I don't know. It's fine. It's just not my go-to. I'm old. I'm getting older. I'm used to just like reading documentation instead of asking my GPU to crank out watts to answer a single question. Instead, I can just like look at the text on my screen and read it. It's fun though. AI is fun. I will give it that. I feel like most of the value that I see or that I get out of AI is that it's entertaining. And I'm not sure if that's just like a novelty, but it is fun. Oh, unfortunately, yes. I am above 30. I hate to say it. So let's see, VCB, bias, collector bias. How can I see what the actual, what's the emitter voltage, right? So VE, right? VBE. This spec sheet does not make a whole lot of sense to me. But if I was from the 70s and I was reading this, it would. Hey, time flies when you're having fun. Yeah, I don't know what I'm looking at. That's okay. I'll just throw this sucker in as a, what was it, an NPN transistor. We're doing parts for simulation at this point, just to get the schematic down. And then this is the, oh yeah, I'll just NPN. And what are we connected to over here? Oh, this is the weird fucked up data sheet earlier, wasn't it? I say earlier. Right here. This guy, T30, he's got this little slant on him. So we're actually connected to, slant is facing that way. We're connected to the emitter. Which I guess makes sense because this pad is square, and I've noticed that the emitters on all of the transistors have square pads, so I think that is on point. So I think we'll take our dude and throw him in here with the emitter. Or throw him in here on the emitter. Boom. Alright, so this is kind of the VDD line that we've got going on. So we can kind of chase down these some more if we want. I think that's all of them. Yeah, this ends over here. This ends here. Wait, what the fuck? How do I get over there? Oh shit, okay. Oh yeah, and this comes from all the way over here too. Bruh. Sheesh. Wow, okay, so we can mark that all the way down to our negative supply voltage, I think. Yeah, see, that's our negative supply voltage right there. Yeah, so our negative supply voltage is down here. We've got some handy salt screening for that. So I guess maybe we can keep going at this one. Because we're over here now. This is, we got our capacitor, right? Our polarized capacitor. And then our VDD is still going from here to here, all the way down here. So what is this thing? Oh, that's a nice resistor. Okay. Let's get that sucker on there. And what is the measurement of this dude? Just so I don't have to come back and do it later. So we got red, red, orange, gold. Red, red, orange, gold. gives us a 22,000, so 22k ohms. So we can test that too, just to double check, and for the practice, because honestly, I don't practice enough testing parts. So 22k ohm. Maybe we want that at the 200k, if it's supposed to be 22k ohm. No. Maybe I need to test it over here. We're probably getting interference from that capacitor, maybe? I don't know. I mean, it is in circuit, so it is going to act weird. We'll just let this, we'll let that capacitor juice up. It's getting close to 22 kilo ohm. You can see as my multimeter juices it up. Bet if we tested it while the circuit was on. I'm kind of curious now. Let's try that. So let me get my benchtop power supply going. I want to set this to 6 volts. And then I'm going to connect this. I'll turn it off. I really want it on before I connect it. So I've got negative here, positive here, and the sucker we're probing is going to be this one right here. So we'll put him in circuit, or, well, he's already in circuit. We'll turn him on at 6 volts. And then we can probe this dude and see what we get. Oh, I guess it's still going to come up to... Maybe not, I don't know. So that may actually be the issue with this board. The voltage isn't, it doesn't stay high as it gets through the board to this transistor, or the transformer over here. Let's test voltages. Oh, it's not on. That's why. I'm dumb. We have to bridge a connection to get the to get it on. So we've got this goes in like this, which means that these two pins, these are the power button, I believe, if I remember correctly. I did this in a previous stream. I'm just going to use these 2 clips to bridge these pins, like so. And if they weren't being a pain in the ass. There we go, stay on there. Alright, now, when we turn this sucker on, we should see some amperage. There we go. Now I bet you with voltage, we can probe this. We actually get stuff. See, we're getting 7 volts over here. 7 volts, 7 volts, but I believe these VFDs are supposed to be powered with 24 volts at a minimum. Here, let's test the resistance of our, is it 22,000 kilo ohm? Yeah, I guess that's not, it's not exactly working right either. That's okay. I think it is a 22 kilo ohm resistor, even if we can't test it. I think we're just not getting the right reading because it's in circuit, but that's okay. Let's go ahead and stick this over here on our resistor. All right, 22,000. I guess I could do like 22K, right? All right, let me, where are we at? This little dude right there. It's not bridged to anything. Okay. So that's our 22K resistor. Stick him right there. And then where else are we going? So we did that dude. Look at the bottom, follow this. This goes all the way back over here. We have two connector connections, and then we have our negative connection from battery. So let's do supply. Let me do VG VDD. Actually, I don't want VDD, I want negative supply. Bruh. That was just supply, right? Reference voltage, normal power. Bruh. Jeez. There we go. Minus 6 volts. Holy crap. Okay, so that is our minus 6 volts. Yikes. Obviously, once I'm done with this, I can come in and clean it up. I probably won't, but I could. Um, can come in here and clean it up and make it a little bit nicer to look at. Let's see. Alright, so before I get started on filling this shit out, I want to go to the bathroom real quick. So, I'm gonna take a quick 10-minute, 15-minute break. I'm gonna set the camera on the breadboard so you guys can mess around with that to your heart's content. And I will be back in a little bit. One moment. Hello, hello. Is this thing on? Is my code still working? It is. Wow! That's incredible! My code never works this long. Okie dokie. Where were we? We're gonna start following some of these traces, right? And start going down. Hey. Oh, I'm on the wrong KVM. Alright, move this up. Let's get started with this, and I think this is a pretty gnarly one. Let's do the hard one first, right? Alright, move all these down here for now. Get them out of the way. I don't want to look at them. Get them out of my mind. And let's take a look at the board. That's going to be this dude right here. This guy. Or there's a way to make my cursor more visible. Probably. Alright, anyway. That's this dude up here next to this connector. I have a feeling we're going to need to make this connector. How many pins is that? That's 4, 8, 9, 10, 11, 12, 13, 14 pins. So 28 pin connector. This is the VFD connection, so let's go ahead and add that. Con, what is it? 02 X14. Odd even. Dude, I don't care. Actually, do I care? Do I care? Is that something I care about? How would I even know? YOLO, I guess I'll just pick one. Counterclockwise. No, let's just do odd even. That one seems better to me. I don't know why. And let's just stick it right here. Sure. So what do we have? Let's maybe we should make another layer. and start mapping out these pins over here. Let's just start with this dude, this transistor right here. Where does he go? Because there may be some other crap that's connected to here. Instead of just, like, these guys, there could be, like, look at this. This all comes over here and connects to the bottom side of this edge connector. And I have that stuff. This is the collectors? Yeah. VGG collectors. Which I have over here. On the complete opposite side. Oh, that's convenient. Okay. Alright. Whee! Alright, so that's our... Is that our emitter? Or do I have this all backwards in my brain? This is the bottom? Okay, so that is the emitter. Yeah. So this is our collector, this is our base. Let's see where that's going. So this wire right here, this one is actually the base, this pin. And that one is going to somewhere. I think that's going to that first pin on the thingamabob. On the connector. I think that's going to this pin. So we can test that with our continuity. That's it. Oops, no, it's not that one. That one? No? So where is that going? This guy right here. Which is... Oh, help, I'm lost. Oh, hold on, let me not mirror it. There, that helps. So it's this guy. This pin, and then where's the connector? This one right here? No? Is it connected to any of these? Okay, so that's that one. The one next to it, or up to, this one right here. That's the pin we're interested in. This is the base of that transistor. see if it's running to any of the pins on that connector. Nope. Nothing. So where's that sucker going? Oh, is that really going to the resistor network down here? No. Nothing, huh? Alright, now I'm just scraping the board hoping to get some. Oh, what is that? All the way over here? What? No. Well. So it comes to this pin on the resistor network. What is that one? Is that the middle pin? We got what, 4 pins on the yeah, that is the middle one. So this dude right here, is that because he's connected to this? Okay, and is this connected to our wire? Oh, I think it is. Because I can see a little test pad. I don't know if you guys can see this. Over here. Oh, this dude right here, this little test pad. That guy. I think that's who we're messing with. So let's take this. I want to take this color. And I think that's what we're putting right over there. Just to double check, and I'm gonna see if I can probe that leg down there. I could probably just clip it. What am I doing? Oh my god, I have clips. Here we go. Wowie! Holy crap. Oh, it's literally right here. Right in front of me. So we got this, going to that, going to this, going to that, go to this, that. This is going to clip onto our negative, like so. Gosh. Okay. I think that is all wired up and good to go. Things are falling off my workbench, but I don't care. Alright, my point and stick. So now that we've got that clipped on and everything looks secure, just to test. I said, oh, I'm testing on the wrong side of the board, right? No. This guy. Right there. I was testing the wrong one. I went to the right of that. Okay. So we got this guy right here. Our pins are making a connection. There we go. This guy, right here. So we've got a continuity test going. And that probes there, and there. So we've got continuity between these. And where I was suspecting is right here, next to this transistor. Got a little pad that goes underneath, and yeah, that's that one too. So that's where that sucker is going. This sucker is going all the way over here to this dude. This resistor network is doing that through a series of tubes. So that's a tube right there. And it goes and it feeds this resistor network, which goes and fucks off and does other stuff. So now that I know where that is going, so this color, this dude, you're going like so. Make sure that I've got, yeah. Blammo. Like that. Holy crap. Okay. So we know for sure that's where that's going. And okay. So I've got that marked out. This dude's marked out, that dude's marked out. What about our collector, which is right in the middle? Where is he going? This collector, I think, is going right over to the base, or the emitter of the next one? This guy goes over here to a resistor, actually. No? Yes. Got this shit backwards again. Okay. Yeah, so this base, or I'm sorry, collector. Right in the middle of that dude. This wire, this trace actually belongs to that pin. So I've got a new one. What is that? Is that a PNP? That's the C828. It's interesting. It seems like this transistor right here is completely unrelated to this one. But this is our C828, which is... Where are you? Oh my god, this one. NPN. Did I get that wrong? Yeah, I think I got that wrong. Because I picked the, got our squiggly boy. This is the pin that we're working with. That's our first one coming off this ground from the chip. The VDD pin from the chip. That guy. And this is a PNP transistor, not NPN. I wrote it down right here, but I didn't get the right one on the thing. Wait, did I? Okay. Am I just confusing the shit out of myself? NPN. Okay, the docs say it's NPN. I'm backwards on everything. Okay. That's too similar. that blood in your urine color. Yeah, that you'll notice that one, right? The blood in your urine color. Okay. And that's going to this dude right here. Blat. And that's coming up over to here. Blat. Where the hell does that go? That goes and starts... okay, so this starts this rail on the bottom side. This starts this whole sucker. That right there. Alright, cool. Starts it? Ends it? I don't know. But that is connected to the rail. And I think... where I want to go from here. These daisy chain into each other? I'm guessing they do. Or maybe not. Hmm. Yeah, see, they kind of... these are all of those transistors up there. And I think these are all PNP. These are all the 7, 8 something and others. Sorry, A749. Yeah, these are all A749s. There are 8 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them. Yeah, 9 of them. Okay. Okay. So now we know those are all connected to this NPN collector over here. This one that goes to VDD. Is that also the... Are those also collectors? Yeah. No, wait, this is the base. So this is connected to the base of all of these. Gotcha. Oop. And then the emitter, which is the one with the square pad, as I've found, also based on the shape of the thing, base collector emitter. So those emitters are, those are all going off doing their own thing. And then it looks like these pins on this resistor network all feed into these into the collectors of these. So let's go ahead and map that out. Okay. So that, I just want to test these really quick. So we've got our base collector emitter. I'm going to test these collectors. And yeah, so they should go over here, and then our next one goes over here. Next one goes over here. This one goes to something else. Probably like, yeah, that thing. And then... Oh, yeah, there it is. 3, 2, and then 1. What about this one? What is this first one? Does that go to... That first one, this goes to... that. That's the start of it. Okay. Cool. So I guess what we can do now... I'm gonna do like a resistor network for the VFD. Because this is... Pretty sure these pins go to the actual connector. It's like if we test... this pin, this central collector pin, over here, I believe it goes to one of these on the actual connector. Yeah, so that's this one right here. What about this one? The collector on pin 2? Where do you go? No, nothing? Oh, up here. Three, four. Oh, look at that. It is alternating. 5, 6, 7. Where's 7? Hello? Where's 7? Oh god. I can hear the kids laughing right now. I just said 6 and now I'm asking where 7 is. uh, Mom, the children are laughing again. So this is pin 6. Goes right there. What the dip, yo? Is it going all the way over to here or something? It's right here. But why? And what are the rest of these pins for? Okay. That one's actually going to the connector as well. Okay, well, I think I have an idea of how that connector is working now. It is, I did pick the right one by picking alternating. Odd even, right? So, can I name this value NPN? Is it 868? $828. Oh, I don't know if I want to do that from, shoot. I want to change them all so that I can see what's what. Well, those aren't the C828s anyway. These are C828s, right? Sorry, A749s. The A749s are NPNs. The C828s are PNPs, right? Other way around? Holy crap. 828s are NPNs. These 749s are PNP. Papa November Papa. So these all need to change, don't they? Shit. Because these are all the A74 whatchahoozits. You know, I should just make the A749. Let me just go into the damn thing. Go over here to custom. Go have this one. Alright, there's our C828. Gotcha, okay. No, I don't want that. Device, where's my custom? Oh. Right? A749? Yeah. Alright, gonna copy that. Paste. Get that right there. Get that right there. Alright, cool. Now we've got our A749 under custom. Right, 2SCA749. Two SA 749, not SC. 2SA. Oops. Rename 2SA 749. Let me save that sucker. Wow, looks great. Okay. And we come in here. Boom, boom, boom. And we replace these all with change symbol to new library identifier 2SA749, right? Oh, I probably have to custom. Um, oh, okay. But they're not connected anymore. No! Wow. Misplaced. Is that annoying or what? Actually, you know what? So shift it over to the left a little bit. Burp. Right? Is that it? Is that what it wants? Call it nitpicking, but hey. Much better in the future. 2SA749. Oh, look at that. There we go. Now they're all connected. Everything is juiced. I think. Collector, emitter, base. Okay. How do I redo? Control Y. Collector, emitter, base, NPNs. Okay, cool. They are... Wait. 2SA custom. Okay, nice. Nice, 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 nice. Now I can come over here. Those are special ones. Meow meow. Hi, kitty cat. So the one that we're dealing with, this one isn't the A749, that's a C828. So the C828 is this first one. This is a C828. This guy right here. Coming off this pin, C828. Yeah, I think we're on the right track. So let me come over here. We will change this guy to a C828 custom 2C or 2SC828. Close. Of course, that's going to be all fucked up too. Also, it's supposed to be PNP. Alright, so we got to change something in here. Um... Alright, so we'll move it over, but I want to change the type. What is the type? Symbol fields? Symbol's not derived from another field? Is this it? No. No! No, symbol prop. There it is. I'm so blind. Okay. Why does it put NP in there then? Instead of PNP. That's weird. what happens if I add a to SC828. I just slap that sucker down. Oops. It doesn't say whether it's a PNP or NPN. Okay. Yeah, I think these labels are extraneous from, oops, when we added them onto the board for the first time. Oops, 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 oops. Yeah, I think that's just extraneous. I'm gonna delete it anyway, so I don't get confused. C5. Maybe I'm misunderstanding something about how to make symbols in this tool, but whatever. Oh, is this just supposed to be like Q? No? Simple property, show name. Huh. I don't know. Whatever. Alright, so we know that's a PNP because the arrow is pointing in. These are NPN because the arrow is pointing out. So as long as we've got that right, then... Wait, did I get that backwards? PNP? Yes. Pointing out is your PNP. These are PNPs. 749s. We're just trying to be accurate with the data sheet. And then these are the NPNs. This is the C828s. This dude, C828 NPN. Okay, cool. Cool, looks like my 3D print finished as well. Start a new one. Alright, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 of those suckers. Okay, yeah, I've got 9 of these suckers. Two, 3, and then because I'm not an idiot, do that. Blammo. So I've got 9 of them. 1 through 9. And how are we going to wire these up? I have no idea. So the emitter, which is the one actually connected to the pins, that's going to be the collector, the one in the middle. Right? Is that what it was? Is that what I determined? So these are the collector pins, and that's going to be, or no, sorry, this is the collector pin. And that's going to be this one. Right here. Okay. And that's going to be pin 1. Okay, that's fitting. So what about this last one? This one's technically the start. Or say this one. That goes right there. Okay. Yeah, I think I have a good idea on the layout over here. I think what we're gonna do that and this one actually goes over to here, this backside. Maybe I need to come over here. That way, like that. Alright, so the collector pin on this one is over to here. Means that this one comes over to here. I feel like I should probably be, oh, hold on, my printer's having a heart attack. As it does. Bruh. I should just restart you. That's hazardous. Yeah, I gotta re-slice this print. Doop-a-doop-boo. Or at least restart it with the proper temperature on the filament. Alright. We'll let that thing think about its life choices. See if it messes up again. Okay, so I don't know if I should rotate this connector or not. I feel like I should probably rotate it. Maybe organize these in a way that, they make sense. Yeah, it's gonna get ugly real quick. Maybe I can take all the odds. Oops. Alright, and those are definitely not spaced the right way, but whatever. Hooray! Okay. It's a bit more readable. Not the best, but... And we have to connect this to... There's the... What is it? The output of this thing? The... collector? Which one? We've got... this guy. That's a C828. Yeah. Yeah. The C828 to a resistor to this whole rail. And then the rail connects to... Since it's a resistor... How does it get over there? Does it just run over there? Yeah, it just runs over there. Over the top. There's a little wire that goes, a little trace going like that behind this transistor. And then this feeds the whole rail. And that's all the base pin, right? This is our emitter, base collector emitter. So all of these base pins. Waymo. I think that works. That works out. It's fairly readable-ish. I can move this in, get a little bit further, but this is being fed through this from VDD. Well, I would say being fed, but that's the emitter. I don't know. I don't know what's what yet. I'm just writing shit down. So we go to cut all of these. We can figure out what pins all of this shit is going to. I already know most of it is going to the emitters. Sorry, not the emitters, the collectors on these transistors. These A749s. But marking them out would be good. Because then I know it's what, just by looking at the, photos. Potatoes. There's a VFD con. Let's do VFDC, VFD connector. Pin 1 is going to be this one right here. I shall deem it so. Wait a minute. No. Pin 1 corresponds to the one on the back of this thing, which corresponds to this one. This one is pin 1. Shall we known it? Right? Yeah, right there. Okay, so this one. Pin 1. And what color do we want for these? Start with pink, work our way towards blue. I think that's fine. So this is VFD pin, VFD connector 1 goes to Waymo. Just do a quick sanity check, just to make sure that we're getting these right. So 4 should have continuity with this top one, is what I'm saying over here, right? Yep, that's correct. 3 is the one beneath it. Yep. 2 is the top one up there. And 1 is the... Yep. So 3... Odds are on the bottom. Evens are on top. Okay, cool. Just for further Confirmation. Did I place that color yet? Yes. Yes. So V55. What did I see? Evens are on the top, odds are on the bottom. Nope, I need to change the color. Whoop. And because I can't see through stuff, whoop. Can't actually set the opacity of this real quick. There we go. Wowie! Wowie! 57 is... This one's going over here to this side, right? Starting from this end, I think. Yeah, that was this one. Oh, that's annoying. 7 is on the top over here. And 8 is right next to it, and then some other shit. And then 9. Okay. 7, 8, and 9 are kind of like afterthoughts. So this spot where... I'll turn this one off. So this one, like right here, like 7, right? How many over is that? Let me count. Let me actually count it. 1, 2, 3, 4, 5. Fifth one over. So, I've done that color. We're counting 5 over. For number 7, pin number 7. So pin 7. Oop. 1, 2, 3, 4, 5. Fifth pin over. It's pin 7, and then pin 8 is adjacent to that one. Oop. And adjacent to that one, like that. Yeah, maybe I want to move those over, these, just so they're actually sitting on their thing. Hey, what's up? La tip. Yeah, I'm just keeping track of pins in Krita. Just mapping pins, so that I can come back and later track it to the actual schematic of what's going on. But if you can see, this is like the PCB of this thing, like the backside of this thing. It's on the desk in front of me, the workbench. And so what I've gone through is I've matched the continuity. These pins are connected to the same colors, and that way later when I want to match these up in the schematic, it's easy to just come in here and like toggle a layer and be like, oh yeah, these two are connected. So this is kind of like the visual connected to the actual board, and then this is the logic connected to the actual traces on the board, so to say. This is like if you didn't have it on a PCB. So I'm just reverse engineering it, so if that makes any sense. And just to double check, I want to make sure that this one's actually connected where I think it is. Yeah. Yep. Okay, cool. So that is this sucker right here. So those are all done. I've got those pinned out. Those are all the collector pins on these transistors right there. Alright, so I think I want to start doing these VFDCs. Like, where are these going? All these emitter pins. These are going down here to this stuff, right? Oh, is that also connected to the connector? No. Yeah, these aren't connected to the connector. Unless... No, I don't think they are. Maybe just bridge them down here, I think. Which one's these? Nope. No, see, I think these bottom pins, these all come from, like, the logic over here or something. Or maybe clock pins. Or maybe one of these resistor networks. Yeah, I'm not sure where this bottom row of pins is coming from, but we'll figure that out. Let's just do like VFD E1. What color do I want? Emitters, do green, I guess. Start over here. Oops. I missed one. DE3, DC4, VDE4. Alright, so I've got those mapped with their respective colors. Now I can come in here and immediately at a glance see what's what, and based off the names of these layers I can see, okay, so we've got our VFD collectors, pin 5, or VFD 5, so over here, that's going in there. So we can see that its emitter is coming down here to this whole row of transistors that I have not even gotten to yet. So let's go back to these, and let's get these on the PCB schematic. Right, so the emitters, those are coming down to a bunch of other crap. All of this stuff, which I do not have on here yet. What are these? These are C828s. Are they all C828s? Yeah, looks like they might be. They're all C828s. Okay. We've got 1, 2, 3, 4, 5, 6, 7. Should have 9, right? Oh yeah, 8, 9. So these guys over here, these 9. We'll need 9 C828s. This guy. This guy. And that guy. So how are these guys going? They're coming off the emitters. They're all in a row. And they are connected up to the emitters themselves. Okay. Okay. And I think I want to connect these. Alright. I don't know if that's the best way to arrange these, but they are connected in KiCad. So Alright, let's backtrack and see if we can get up into this stuff. Since we've got all these hooked up, these kind of will leave dangling. I wanna get into this whole section right here. Because I don't think this is the power. I think this is still like maybe like the voltage gates for the VFD power. So I want to get into this section right here, which is we'll hide all these. We don't have to worry about them. Can I group all of these? Let me see. Oh, hell yeah. VFD transistor array. Okay. We do that down here too for this sucker. I don't have that mapped. I don't know what that is. What is that? Oops. Nice. Oh, it's all the leaves. No, I want the ones that are in the group. There we go. Okay, so I can hide that whole sucker. Alright, and the pin, we were looking at VGG, right? No, not VGG. Is it VDD? Yeah, VDD. So this is the next sucker that was on our route. This pin goes from here to here. Yep, from here to here. And then we've got a capacitor right there. And what that sucker is doing, I have no clue. So let's start tracking some of the stuff on the other side of that. To make a new layer, this is going to be VDD, C1, I don't know, we'll just do C1. And let's pick a color because it doesn't matter. We'll do this one. And that's all going to this. Is that going anywhere else on the board? Eh? Oh. Wait a minute. Yeah. Okay. So we've got a resistor over here. And then I think this is our transformer. I think this is the part that's not working. That's where our calculator doesn't work. But I'll ignore that for now. Move this sucker up. Put a resistor. Connect that. How fat is that dude? So that's a red, red, black, gold. $22 ohms. Alright, now I want to test that. It says that it's 22 ohms, then let's find out. This dude right here. Right? But right there. 22 ohms? What do you got? Hey, look. That looks like it's 22 ohms to me. I mean, close enough. 22.1. So we could jot this guy down as value 22. 22 ohms. So I've got a resistor. Arduinos are great. Arduinos are great if you're new to hardware, or if you're new to software as well. You want something to tinker with, I think they're great options. The Uno, the new one, or is that the one that has the screen on it or something that's ARM-based or something? It's got like a x86 core and an ARM something another. I don't know. And it's got the screen on it or something. Or not screen, but LED array. I guess it's the Uno Q, right? I don't know. Arduinos in general are pretty neat. They're nifty. So that's that resistor. And then I think this is a transformer. Let's see what kind of footprints KiCad has for transformers. Single primary, single secondary. I don't know. I really don't know a whole lot about transformers as a part. I wonder if there's like a 6-volt to 12 or something. Or sorry, not 12, 24 volt. Alright, well, we'll do this. Transformer, single primary, single secondary. And we'll pull this off. I don't think that's what it is. We can come in here and change it later. Yeah, I think they're great. If you don't have any experience with microcontrollers, or even if you do have experience with microcontrollers, I think Arduinos are great. There's a lot of things you can do for them, and more importantly, there's a lot of guides and a lot of documentation online on how to use them, how to code for them, which is very useful. So even if you don't find yourself like enjoying the hardware side of things, you might find yourself enjoying the software side of stuff, and you might want to write more code for it, or you might find that, oh yeah, the coding kind of sucks and I just want to focus on the hardware. Well, the Arduino is kind of like that bridge. So we got our capacitor going in that, and then also going in the transformer, and then yeah, so that's what that's going to. So let's take this coming off of here. And we'll just do that. Is that coming down over here to this thingamabob? Yes. Okay. So that's coming over here to a switching MOSFET thingy. Switching transistor, I think. Who knows? This thing is coming down to here. Boop. Just like that. Alright, so I think that chases down. Oh, I gotta do this right there. Alright, I think that chases down that whole path. So we can move to... What's another one? This guy right here. What are these transistors doing? Do I have... I think I have this dude. What's this green coming from? That's VDD14. Okay, so I've got VDD14 coming to this. Actually, I think I want to delete all this stuff. I put this on here earlier. I think it's just confusing me a little bit. So we've got our capacitor, which goes to a resistor, which is this dude. Then I have another transistor. How does this VDD get over to here? How's that happening? Is that this right here? Oh no, it's this whole path. Okay. And which one was that? That was this thing, right? The I226A. Okay, I don't have this thing as a part yet, so let's go make that. Alright, you done forgot it. 2SC1226A. 2SC1226A. Right, 2SC1226A. And that is a NPN transistor, so let's just copy the symbol. Alright, so this is our NPN. Like so. That's what this guy's connected to, right? This resistor goes down to one leg on that thing. One leg on that thing. USC. Let's see, custom. Cannot remember what pin is what. Okay, so that one is emitter is going to base collector emitter. Well, let's look at the data sheet. So we're dealing with this package. So if that's our emitter, it's on the side with that, that makes sense. We've got our collector and then our base. Okay, so meaning that this is our emitter. Emitter, collector, base. Our base pin is connected to that resistor. Over here. Base pin is connected to that, and then the emitter pin is connected back to this VDD, right? Yeah, okay. And then where is the collector? Where's the collector going on that sucker? Like it's going up to this capacitor. So we've got a polarized capacitor. I think I already put this one on the schematic. Oh, I did, and then I just deleted it. Okay, whatever. So we've got a polarized capacitor. Hey, what's up, Purple? How are you doing? So this was connected to the positive end of our polarized capacitor. Oops. Like so. And then this was going back to the VDD line, right? Yeah, that's a good question. I'm pretty sure they were like wave soldered or something. Which is like a process where they have like a big old vat of like solder and a big old vat of flux, and they'll like have the PCB on an assembly line just kind of coast across, and all these like pins will kind of dip themselves in the solder. And the reason why I say that is because this board, when I got it, was absolutely caked in flux, like just dried up flux. So pretty old style manufacturing method, I think. So this is that capacitor, right? That's the... Oh, that actually does not connect. That's really funny. Wow. That is a squiggly boy. This dude, this trace right here, actually does like kind of a this number. It was like ooh, and stops right there on this thing. Doesn't touch anything else on the way there. That's really funny. I don't know. Maybe. That's a really funny trace. Okay, so this guy's going all the way up to another capacitor. I think that's a different one. Same style of capacitor, but different, this is 103K 50. And in this polarized capacitor, are you touching? Where are you? Is that you? Oh, I'm testing resistance. Yeah, so that is touching. So this polarized capacitor is coming back over to the transformer. Here, let me oops. No, wait, this is the other side. This is the other side of the transformer. I think typically that's how the pinouts on these things go, right? Oh, is that like a, shoot, what's the word for it? Kind of like a sponsorship or grant thing. You just gotta learn some stuff and put together a PCB, I guess. I think the reason why the schematic exists and not just build directly to the PCB is because your schematic or your parts, kind of like how I don't really have a real reference for what the values are on these transistors. I just know that they're NPN or PNP transistors, right? So when you make a schematic, it's really just kind of the logic of the circuit and not so much the actual where does everything go, you know, because like the where does everything go on the PCB is a completely different question of how is everything connected. So the schematic is sort of like your how is everything connected, and the PCB design is the what parts are we using and where do they go, right? So when I go to actually make a PCB for this, if I ever do make a PCB for this, I'll have to specify what the values are on this actual transistor instead of just saying, hey, yeah, this is an NPN transistor. I'll have to say, okay, these are its characteristics. And then also, this is its footprint. So in its footprint is like, how does it attach to the board? So like this one, all of these are basically through-hole components. Even this integrated circuit is a through-hole component, and so that's their footprint. We've got this thing. These like engineering diagrams. These kind of show like what the part looks like, and this is the footprint essentially. And the footprint tells manufacturers, hey, if you take this part, here's its specifications, and here's how large it is, and how it's going to fit on your board. And so that's where you actually do the PCB design, is you're designing, hey, where do these parts go? Where do these physical things fit and sit on the board? And then the schematic goes back and it says, hey, where do we run all the wires and run all the traces to? Yeah, exactly. The footprints are how the symbols translate to connections on the PCB. Yep. Yeah, so your symbol is like this. This is just my symbol, my transistor. And then when I go to the actual PCB phase, I'll specify what kind of footprint this transistor has. And that specifies, hey, this is how large it is, how many pads it has, where those pads are in relation to each other. And then you stick it on your PCB somewhere. It also helps to have a schematic versus like a PCB design, because if you think about, like say I was actually designing this thing, and I'm not just reverse engineering it, but I was designing a calculator, and I came in here and I realized, oh, I need to change where this pin goes, like where this whole trace goes. If I had already done the PCB design, then I would have to reorganize everything. I'd have to move all these physical traces that I've already mapped out in my PCB design, instead of just moving a logical trace in the schematic. No, I haven't. Not yet. I'd like to get to a point where I have one printed out. I've just never really gotten to a serious enough point to print out a PCB. Most of the stuff you can make with like breadboards, or some existing PCBs. Like if you go out to like DigiKey or something, you can buy breadboard PCB and then just use through-hole components and solder and stuff. So I've never had like a major need for it, but I would like to, just because it's like the next step of practicing and, you know, getting the skills and ability down. And you'll figure out like what's actually bad and broken once you ship it out to somebody to manufacture it. So that's going back to that transformer, which is this dude right there. I wonder if I should make a color for him. VCC VDD. Yeah, I can see how you'd want it to be like perfect. Don't let trying to get things perfect stop you from actually making stuff though. There's a saying where it says, don't let perfect be the enemy of good. Something like that. So one of the things that you can do is, if you make a like a PCB design in KiCad and you're still not 100% comfortable with it, get to like where you're like 80 to 90% comfortable, to the point where you feel like you know what's going on with it. And then if they ship it to you and it's broken, then you'll at least be able to put some bodge wires on it and be able to make your own traces and fix it, essentially. Just try not to make it so complicated that you can't hack a repair out of it. You know what I mean? It's like if you misplace a trace, or you don't place a trace, make it so that you can get in there and actually put a wire down and then and fix it if you need to. Got some debug pads, like test pads and stuff. Test pads are great. So if you design your schematic with a couple of test pads, for the various things. That way, if you do end up messing something up, you can go in there, you can put a wire down on your test pad and put that wherever you need it to go, if that's a possibility. But don't let it stop you. Don't let the thought of like, oh, I'm gonna mess something up, stop you from actually, you know, trying it. If anything, you'll learn from your mistakes. You make mistakes and you'll learn from them, and you'll overall have made something from it. I want the, I don't know what to call this. Let's call it, what is the name of this thing? 01126A. One, 2, 2, 6A. No? 1, 2, 2, 6A. So that's the, let's see, collector. Oh yeah, plenty of times. I have like a whole pile of projects next to me right now that I want to work on. But unfortunately, it's just one me. What color do I want? I already have a color, so let's do this one. We'll stick this guy right here. And then it's coming up to here. There we go. So now I know that is related to that 1226A. The best thing to do, if you get project ideas, is to write them down, in my opinion. That's, at least I think that's the best thing to do, so that even if you don't get around to it later, you can have it written down, and you can either cannibalize it for another project or another idea later, or you can improve on it. And then, if you ever get around to it, you know, getting some time to make the thing that you want to make, or do the thing that you want to do, then you can work on it. And you'll be more prepared because you'll have a whole bunch of documentation and a whole bunch of like stuff that you've written down and already, you know, worked through in your brain. Because trust me, you will forget the stuff. Is that bridged? I don't think that's bridged. What are we looking at? Oh, it is bridged. Okay. Yeah, so this is... That's bridged with that, which means it's bridged with that. And then where does that go? Does that go to that capacitor? So this is that leg on that dude, and it does. Okay, yeah, so it goes to that capacitor, and it goes to the leg on this thing. So this right here. And this capacitor, right? This one right here, I think. No. This guy right there. Yeah. Yeah, that's a very good point. There's a lot of sellers online that will mark up Arduino kits. But overall, you know, I think it's a learning thing. If you use it as a learning tool and you just kind of like get things as you need, that's a pretty good way to do it. But the trouble is like if you're first starting, like if you've never done microcontrollers at all or any sort of electronics thing, if you do get like a good kit that has a wide variety of parts, you can do a lot of different projects with it and learn what all the different components do and what they can be used for. I like the Raspberry Pi 2040s are a lot of fun. Those are really fun microcontrollers. They've got I think it's WaveShare, right? Oh, the thing is broken. Rip. The breadboard. Let's see. WaveShare 2040. I really like these. Mostly because they're inexpensive, but the problem is that their GPIO is small. But they're fun. You can do a lot of things with those too. Yeah, they do that. They count every individual item as a component. Yeah, make sure the variety, you've got a nice extensive variety where it's not just a bunch of LEDs and not just a bunch of switches or buttons or something like that. Because realistically, there's only like a handful of like functional parts or active components, so to say, and then there's a handful of passive components. And if you do a couple web researches on what like active components are and passive components, you'll get an idea of what is out there and what you can mess with, like relays and stuff. There's a bunch of different types of LEDs. Like you can get addressable LEDs, RGB LEDs, or even just regular LEDs. All sorts of fun stuff. What is all this other junk doing? So this is all kind of driving this transistor right here. All of these pins that I have. Oh, WaveShare, their website directly? Honestly, I've never directly ordered through WaveShare. I'm pretty sure you can. I'm certain it's fine. I guess it depends on where you live. They've got a lot of other stuff though. I would say if you're new, don't get the 2040 0. What is it? They've got let's see. And the only reason why I say this is because it's a little bit more fiddly. So they've got one like this that's actually got like a breakout board on it with pin headers and everything. This is a much better, and it's also got peripherals and stuff. This is a much better like learning platform. So you could get like one of these. This would be like your Arduino replacement. So instead of an Arduino, you could use something like this. It's all microcontrollers at the end of the day. But these are nice because it's got a nice development ecosystem around just the board itself, this particular board. And it's got pin headers, so you don't have to worry about soldering stuff to like the tiny little through holes on the 0 version. But once you've got like a project and you've got something figured out and you want to move away from the test board and you want to actually have something smaller and more compact, then you can get the little zeros. And since they're running the same chip, all you have to do is make sure your hardware is the same, and you can load your code onto it and everything. So let's go ahead, and since we know what's coming off of this pin, let's go into this capacitor. Let's follow that through. Collector. Wait, was there a emitter coming off of that? And going back to the... Yeah. So we have to come off over here after this capacitor. That's our collector pin. Oh, wait a minute. Okay, so the side that is connected to the... What we gotta do? Okay. So the side that's connected to the transformer is what is actually, at least I think that's transformer, is what is connected to, see this is bridged. That's coming all the way back over here. Alright, and then the pin that isn't. No, I also wanted to check this sucker. Oh, I did check that, right? Yeah, those are connected. Continuous? Continuous? Continue? I'll put that sucker there, that way we know. Alright, have a good one. Thanks for hanging out. Yeah, I think I might be wrapping up and hopping off myself here in the next handful of minutes. I gotta eat some dinner. And I think my husband's home from work, so... Let's see. We got this capacitor right here, goes to a handful of other things. So we've got 2 resistors coming off of that, and a transistor, and then this capacitor. And that dude. So we've got a handful of things coming off of this line. Alright, so we'll get 2 resistors in here. The first one is going to be... What are the values on these? Are these the same? No, they are not. So we got an orange, orange, red, gold. Which, if I remember correctly, that was what, the 30-something K? 33K? Orange, orange, red, gold, 3.3K ohm. And I want to test that. which is this one right here. Be 3.3. Yep, 3.37. But that's okay. And then this next one is $56K. Is this a 56,000 resistor? Like that's what it looks like. 56K. 56.1. Oh. We'll see what that next one is. This one, oops. What's that? Green, blue, orange, gold. That's a wild one. Green, blue, orange, gold is 56K. Yep, that's what I measured. 56,000. That's just like my modem. Alright, so we've got a 56K resistor, a 3.3K. Which one comes first? It's technically the 3.3K. There we go. Right, so this is our 3.3K, this is our 56K resistor. Let's find out where the 3.3 is going. We'll follow that one a little bit. So that's over here. Where does that go into the transistor right there? Probably. Yes, but it's going to the emitter pin on the transistor. And that's what, a 749? What is that? Holy shit, it's a new one. A564. I don't have this one. Uh-oh. A564. Nope. Get out of here. Go with Firefox. A564? Hey, is that page 17? A564. Oops. to SA564. I'm gonna move these around, or organize them. Alright, here's our 2SA564. What is this thing? I didn't even look to see if it was a... Damn it, I do this every time. Alright. Here we go, it's a PNP. Used for low noise amperage. Or amplification, sorry. Let's see, page 15 and page 24. Wow, okay, so now I can see. There we go. So PNP transistor. We do not have this one, so let's go ahead and make this over in our KiCad real quick. A564. Two SA564. And what was it, a PNP? PNP transistor. PNP, we will copy that, paste it, and stick it right there. Now where the fuck does it go? It's this sucker, right? Or right after this one. And then this connection goes to the emitter. All right. Oh, nice. Somebody tried to print an Among Us. You tried to print an Among Us purple? I wish the font would show it. That'd be really funny. I need to find a font that'll show the Among Us. Alright, what else do we have over here on this thing? Actually, I think I might call it here. I might call it quits for now. Made some decent progress, I'd say. Got this whole lower half started, sort of. Yeah, I bet it looks really cool with all the layers unhidden. Which slightly faded one. And this one right here. Or this one right here. That look pretty faded. Yeah, the traces on this thing are not looking very good. There's some really thin ones too, like this dude up here is like super thin. I mean, I'll have to test it at some point when I come in, like, probe it. You know, look and I see, oh, okay, that isn't actually connected, I guess. I don't know. We'll see. Let's see. Actually, I want to group all of these. Wait, what are those? Those are segment drivers. Wow, that is, gone through and put down a lot of dots. Yeah, it could be a bad trace. We can check that right now. Put it in continuity first. Yeah, that looks good. Here, we'll go through and double check, because that's not a bad idea. We got that one, which is good. This one looks pretty gnar, but I think it's good. Yeah. So that's good. This one's really thin, but also tests good. What else do we have? Gnarly looking traces. Those are not continuous, which is good. Those are not continuous, which is good. I think that's most of the really ugly ones. There's probably some on the other side that that are pretty ugly. They're a little bit harder to reach, I think. Yeah. Okie dokie. Well. Oh, the numbers on the continuity. It's also diode test. So if you touch the probes together, it's actually running a voltage through it. And so if I have like a diode, like an LED, like this one, I just take off the breadboard. I think blue is a bad idea. Hold on. Blue doesn't work as a diode test because the voltage of the multimeter is too high or too low. But it lets you test a diode. It basically runs like a low voltage through the diode, like so. I can get it to hold still, and then it tells you what the forward voltage is, effectively telling you how much power is required to light up the diode. It also tells you like which one's positive, which one's negative of the legs. Let's see, I cannot get this thing to hold still. Here, I have a thing. Just use the thing. Yeah, so I don't... maybe it won't do it for a green one. Maybe it'll do it for the red one. Let's see. It should tell you what the forward voltage is. Maybe this multimeter doesn't do it, but I think some other multimeters are supposed to. When you do like the diode test, it'll tell you the forward voltage. Maybe this one does it immediately and then stops telling you. I don't know, but that's the gist of it. It's the forward voltage of the diode. Should be what it actually takes to power the diode up. So. But okie dokie, yeah, with that, I'm going to hop off. Been streaming for quite a bit. So, oops. If it works. Probably not. My code is jank. Yeah, I'm ending for the night. I gotta get off and get something to eat. It's been a minute. But yeah, voltage drop is like, so forward voltage is like how much voltage is required to actually get the LED to light up, right? So for like a blue LED, it'll be like 1.5 volts. I don't know however much a blue LED is. But say it's like 1.5 volts is your forward voltage. That's how much it costs, how much voltage it takes to actually turn the light on. And then once you've got power running through it, it'll consume a certain amount of current. And that consumption of current will cause the voltage to drop. So if you measure the voltage after the diode, you'll measure a little bit less than before the diode. Because the diode is consuming current, it reduces the voltage on the other end of the diode. And so that's your voltage drop. So, but I hope that helps. And I hope you guys enjoyed the stream. So I'll probably be back on tomorrow or later on this week if I'm not editing videos. And yeah, so if you wanna see more of this stuff, you wanna support the channel, You guys know what to do. There's some stuff in the description. I've got a Patreon. You can be a YouTube member, that kind of fun stuff, or you can just watch my content. But yeah, thanks for hanging out. I will see you guys later. Bye.